Go. Hello. This is the group team name is Huber's Not a Funny Name. Please don't laugh at him. I'm Joe.
Ray.
This is
Hubert.
yeah, okay, we're group of three and we're here to showcase this is our 5 minute video submission for our project. And so here's the code for our project. We've got some files we're going to end up going over as we demonstrate. And our project is actually posted and published as a whole website. So you can go to the web, post in this link. It's a real website. You can go to it on your computer, your phone. Please use your computer. It'll go to the website, and here's our website. Maybe I'll move the Zoom dock a little up and away, but here we are. You see we've got some pages about us, example use, technologies used, and we're just going to go through a demo of the website. And so this is our project essentially searches Wikipedia, right? And so we're going to specify some nodes, say UF, University of Florida, and this is a live search. These are real pages on Wikipedia. When you're using it, please click on one of these and don't just put like something like this. It's not made for incorrect names. Make sure you click on one of these and it'll actually update to that. You click create subtree search, and this is the longest part. It's actually indexing Wikipedia page by page, sending on the order of a couple hundred GET requests to try and find out what pages there are and what nodes they connect to. And after about 30 seconds and some processing power, we're here. All right, you can zoom in. If you have a touch screen, this works really well, and you can see University of Florida. You can move the nodes around, and these are grouped with each node has a gravity, and then each edge is like a spring. And so we end up getting related nodes kind of close to each other. These aren't related to each other, this cloud, but they're related to this node, which wants to be far away from all of them. And so what we can do is we can perform a kind of search on this. So we know that UF is in there because we indexed it. And of course, we know this is a directed, connected, cyclic graph with no weights, right? Because we got all of this. We're performing basically a breadth first search from University of Florida out to other nodes. And now we can traverse this with different search algorithms, right? And so University of Florida to, let's say, the Atlantic 10 conference. That sounds cool. Atlantic 10 conference. And there it's the top result. You click on it and we can perform breadth first search, depth first search, or we can use Dijkstra's algorithm. So I'll just zoom out a little so we can actually see the result. And we click on breadth first search. We get some information about what happened on the back end, the request sent, the pages visited, and that final path. And if you scroll up, you can actually see the path was highlighted in red, right? And we can do the same for depth first search. Here we are. And finally, we can do the same for Dijkstra's. And under the hood, these are running different search algorithms, and the shortest path is the same, so you'll see the same red path. Switching over to the code side of things, and it doesn't have to be, just quickly, it doesn't have to be between, oop, I lost the graph, but it doesn't have to be between, I scrolled too far, zoomed too far out, University in Florida and Atlantic. It can be between anything on this graph, right? It can be between any two nodes that exist on the graph. Hopefully it'll pop up again because I clicked like recenter. Yeah, there it is. So any nodes that are on here, you can pick any two and it'll give you a path between them. Now, go to this code. So I'll drag the Zoom dock out of the way again. Okay, so here are the algorithms Ray implemented. He's going to scroll a little and just tell us about them.
So, yep, this first one is going to be breadth first search right here. Very similar, very what we learned in class. Very easy to implement. Also debugged a couple of things in these. Here is going to be depth first search, which we used as well in class. Learned a lot about in class as well. And as you see in the website, you can click those buttons. This is the code I wrote. So if you click the buttons on the graph, you would get breadth first search or depth first search.
All right. Next, we have Dijkstra's by Hubert. Here's that.
Yeah, so again, we also learned about this in class. It's just a optimal algorithm for searching the shortest path in a weighted graph with no negative edges and no negative cycles. And of course, this is an unweighted graph, so it performs very similarly to breadth first search. And the implementation is as standard Dijkstra's.
All right. Finally, I'll just go over main with the little time we have left. You can see it's just we're doing some file system routing with public, and then we have routes for the main page. We have that live search, and then we have creating the tree. When you actually go to that first button you press, takes creating the tree. This is the longest kind of time-wise. And we have performing different searches. This is just an example. It's going to disappear. We have breadth first search, depth first search, and Dijkstra's. And these are the functions that get called, and you can see perform search here. And these are kind of our page responses, creating the graph, searching for 5 pages. And yeah, thank you for watching, and we hope you like our project.
Good.
That was dub. That was a dub. We got to edit it a little, just end meeting for all, and it should just